Hi guys, so we'll solve the third question of the last weekly contest on Leetcode. I'll suggest you go and read the problem, understand it, because I'll straight away dive into the solution. It's pretty simple. If you know the knapsack problem in DP, how I know that when I read the problem, how I got to know that this is the knapsack problem, because if I take this example from the question and I try all the possibilities, if I choose one, I cannot choose -1 or 0, right? I cannot choose 2 and 3, right? So in order to just worry about one direction, we can sort this power array and see that we don't have to worry about the negative side of every index, right? So what we can do is we can sort it, and if I do a try run, I get 1. Now I can choose 2, I can choose 1 again. There's nowhere it is mentioned that I cannot choose the element again. I can choose 1 again. I have to choose 1 again actually. So 2, I cannot choose 3, I skip it. I can choose 4, so I take it. Now it's one of the possibility that gives me 6, but not all the possibility. If I skip 1, I can choose 3, but I cannot choose 4, so eventually 6 will be my answer. So this is a textbook knapsack problem, but there is a true dynamic programming solution as well, which I'll explain it using this example. Sorting is required in here as well. So I sort this. This will give me what? 2, 2, 3, 5, 7, 8, 9, 9, 10, 10. So this is my sorted power. I will have a maximum damage. I'll have an array which is called the maximum damage till current index. It just means what it is named. So it is named maximum damage till current index. It'll have these many values, but what's the first value? Till this point, what's the maximum damage? Because we cannot have negatives. If you see in the constraint, we can always afford to choose the first step. If I skip it, I'll have 0 damage, but if I take it, I'll have more damage, right? And then, as the name suggests, I need the maximum damage till this current index, so I'll choose 2. This is our base condition. All the other values will be 0 as of now. We'll traverse and fill it as we go. So 2. So now we take care of duplicates, right? I can always choose 2. Even if I've chosen 2 earlier, I can always choose 2 again. So I can have a duplicate array, not array, but occurrences. Occurrences is a good word. It will be 2 right now because I have encountered 2 times. So right now at this point, I can have maximum damage of either 2 or 2 plus 2 or 2 into 2. Why I say 2 into 2? Because occurrences into the power of I at current index. So this will be 4, because maximum of 2 and 4 is 4. So now I move here 3. I cannot choose 2, right? I cannot choose 1. If I choose 3, I cannot choose 2, I cannot choose 1. But if I skip 3, I can have 4. 4 maximum damage till current index, right? I can have 4 here, or 4, or I can have 3 into its number of occurrences, that will be 1 plus the maximum damage till current index of what? Of a index, of a safe index, I'll call it. This safe index is something which we can just do a binary search. I'll do a binary search on this value because this is sorted and I'll get the first value that is equal to power of I minus 2. That is, power of I is 3, 3 minus 2 is 1. I'll get the first value which is 1. In this case it's not there, but suppose it was there, then I will get that index and I'll subtract 1 from it because it cannot even include 1, right? So you will get it with further numbers, further spells. So I will have this, for this example this will come out to be negative, not negative 1, yeah, the safe index will come out to be negative 1. So in that case I'll just skip this part, I will not add this, it will be 0. So in that case maximum of 4 and 3 is 4. Now I'm here, right? Here I can, the number of occurrences will be 5, the number will be 5, number of occurrences will be 1, the maximum value can be 4, so 4 or 5 into 1 plus the maximum index, maximum damage till current index of a safe index. In this case the safe index will be the index, the last index of power of I minus 3, or I can say that the first index of power of I minus 2, and this whole thing I can do one more minus, and this will be equivalent. So this is what I am going to do. I am going to use lower bound technique and try to find this safe index, and I'll do is minus 1 to it. So in that case safe index can be negative values, right? If safe index is greater than minus 1, only in that case I will add this value, otherwise I won't add. So this is how it will be done. Let's solve the problem, we'll get more idea. Sort power dot begin and power dot end. I will have a vector, I'll call it DP instead of maximum damage till current index. This will also be long. Essentially we are storing the answer, and answer will be long because of the longer constraint. The power size, actually I'll take this power size out, right? The first value will be the spell, the first spell, long answer equal to 0. Alright, so the duplicate or the occurrences actually will be first 1. This will be 1, you will understand later on, but this will be 1 initialized to 1 so that I can handle the other cases easily. Equal to 0, actually I started with 1 because the first spell has been taken into account. n I plus plus, and here I'll check if the occurrences if the previous value was equal. In that case I'll do the occurrences reset to 0. Otherwise I'll increase the occurrences by 1. And here is the first value, the minimum value that I can have. Right now I can initialize this value to be this is 0 actually right now. This is 0, and I will add occurrences into the power of current index. This will be long, and this will be I. Now I'll do a binary search. So I've taken this minimum. If I take this spell, what all duplicates I can or occurrences I have at this point, I'll take all those at least, and I'll also take the previous spells which I'm allowed to take. So for that I'll do a lower bound index, safe index is equal to lower bound power dot begin comma power dot end, so not end, till this current index comma what I'm searching is power of I minus 2, power of I minus 2, and I'll get the index instead of the iterator, and I'll subtract 1 because I need this value power of I minus 3, last index of power of I minus 3. So I get the safe index if safe index is greater than or equal to 0. Greater than 0, it can be equal to 0 as well. It can be equal to 0 as well. So in that case I will add dp of I with what? With the maximum current, maximum damage till the safe index as well. Right. So dp of I is equal to the safe index. So now I have all the values, but I will take only the one out of this dp of I and my answer, whatever I have at this point, whatever the maximum out of the two is. So dp of I will be maximum of answer comma dp of I, and answer is equal to maximum of answer comma dp of I. This can be a little confusing, but if you try to debug it, this will start making sense. It's basically saying that either choose 4 or choose whatever value I have. This 4 is nothing but the answer at this point, and then if I get the maximum, then update the answer as well for the next iteration. So this will be my answer. Okay, let's see if this works. Safe index. Actually, if it is not equal, then let's reset it to 0. And this works. Let me submit it. Okay, 10. My bad, I should have initialized this answer to power of 0 instead of 0, because I can always choose the first bit. Now it should work, and it's pretty efficient. Thank you for watching.